since U-Nova was released, people started wondering, what is this sorcery? Well, it falls under the deep learning category of generative AI. Gen AI is not exactly new, let's say newer than Twitter, but older than TikTok. Generative AI refers to a subset of AI techniques that can generate new data by learning the probability distribution of the existing data. So the cool thing is, the outputs of some Gen AI can be something other than just text. It could be a new image. In this video, we'll discuss about 3 popular Gen AI model types, briefly, and maybe in future videos, we can go deeper. It's in the name. Generative adversarial networks are mainly used with images and can create new, high-quality samples fast. As the name suggests, GANs are made of 2 neural networks, a generator and a discriminator, which are pitted against each other. The generator tries to create new data that looks like the samples from the dataset. The discriminator tries to differentiate the fakes created by the generator from the real ones from the dataset. The goal is to train the generator to create samples that are good enough to fool the discriminator, so that it cannot distinguish between the fake ones and the real ones. So, there's an extension of GANs called conditional GANs. In C-GANs, the generator should create the new samples based on a specific condition given as an input. So, they can be used in image-to-image translation. Pix2Pix is a well-known paper that uses this technique to perform many tasks: sketch to photo, grayscale image to color, aerial photos to maps, and many more. We'll put some links in the description so that you can explore more.
Terrific.
Really bitchin'.
You've probably heard of deepfakes. Those are mainly powered by GANs. There are some popular YouTube and Instagram accounts that are dedicated to deepfakes. In case you didn't know, deepfakes can be used to transfer features like facial expressions and actions from a person in a video to another person. You can basically become a puppet master. Just like GANs, diffusion models also mainly deal with images and create samples of an even higher quality. Also, they can generate data that represents the entire distribution of the dataset, whereas GANs usually collapse to the mode of the distribution. However, diffusion models are generally much slower than GANs. The whole diffusion process is made of forward diffusion and reverse diffusion. Forward diffusion adds noise iteratively in a specific way to the original samples so that after infinite steps, they will become pure noise. Practically, the number of steps depends on the model. As the name suggests, reverse diffusion tries to undo or revert the forward process. It starts from pure noise and attempts to recreate the original sample by iteratively denoising. During training, it learns this reverse process to estimate the distribution of the dataset. You might have seen models that take natural language as input and create images based on the text.
Show me a video of a kangaroo playing badminton with a pirate.
Like DALL-E or Midjourney. They use diffusion models. Actually, if I remember correctly, DALL-E version 1 used a type of variational autoencoder. You can use the decoder of a VAE to create new samples. However, in DALL-E version 2, they switched to a diffusion model to achieve a better quality. Unlike the previous 2 models, transformers are mainly used with natural language.
You're wonderful.
Well, we already discussed about transformers in one of our previous videos. We'll put the link in the description. So in this video, we'll talk about different transformer types. Transformers are usually made of an encoder and a decoder when sequence-to-sequence mapping like natural machine translation is required. For example, Facebook's BART and Google's T5 are encoder-decoder transformers. There are also encoder-only models. They are good when understanding of the input is required, like in sentence classification. However, they cannot generate text. BERT models belong to this category. It's in the name. In case you didn't know, Google uses BERT to understand search queries. On the other hand, decoder-only models are good at generative tasks, like text generation. Latest GPT models belong to this category. Yes, the large language model that should not be named is a decoder-only transformer. Training of a transformer depends on its objective. For example, BERT is an encoder-only model, and it was trained using masked language modeling and next sentence prediction. In masked language modeling, some words were randomly masked out and BERT had to predict the most likely candidate for them. In next sentence prediction, BERT had to predict whether one sentence followed the other, given two sentences. On the other hand, GPT-3 is a decoder-only model, and it was trained to predict the next token given the preceding tokens. You can think of tokens as words, but they are not limited to words. Since GPT-3, OpenAI did not publish the weights to their models. It's also the case with models like Palm by Google. So, what can you do if you want to build on existing transformers since you don't have enough computational power to train your own? You can use pre-trained open source transformers like Bloom from Hugging Face or OPT from Facebook. Okay, we hope that now you guys have a good understanding about widely used generative AI model types, how they are trained, and their applications. Check out the links in the description if you want to learn more. See you in the next video.